Hello and good day, everybody out there seeking microgrid knowledge. We're here to help you. I'm Rod Walton. I'm managing editor of Microgrid Knowledge and also of the website and the Microgrid Knowledge Conference, which will be next April in Dallas. And we hope you can join us then. I'm happy to be here today, though, with Jason Petermeier, who is Chief Operating Officer of ELM Microgrid and ELM Solar, a distributed energy resource and microgrid provider, which is involved in the energy transition on a lot of fronts. Hi, Jason.
Hey Rod, how's it going today?
Good to meet you and good to chat with you. I appreciate you doing this quick chat.
Yeah, happy
Um,
to be here.
yeah, Jason is expert on a lot of sectors as well. In addition to his decade with the ELM companies, he has successfully navigated a career that includes deep dives into aerospace, defense engineering, microgrid controls, and deployment. Jason, it's great to meet you, as I said. Thank you for taking the time to talk about DERs and their impact on the grid. It is an exciting time. It's also a problematic time in the industry, right?
Yeah, sure. I mean, the industry as a whole is relatively new here the last 10 years. So figuring out how to navigate these waters is definitely a challenge that everybody's working towards to solve.
Yeah, true, very true. Well, I know that you and your team at ELM have done some proven microgrid technologies and projects on everything from Caribbean resorts to manufacturing facilities to a church in Texas, a project I remember recently, literally across the board for use cases. So what's maybe the most unique use case for a microgrid that you and ELM have been involved in?
Yeah, sure. So ELM, we kind of target what we call the market space, the C&I market space, and we've deployed systems from fully islanded systems down in the Caribbean. We do behind the meter applications at commercial businesses, as well as distributed energy systems with utilities. Locating these energy storage systems locally at substation. We typically focus on products in the 30 kilowatt to multi-megawatt type applications. Um, and yeah, the different, we get involved in a lot of wide-ranging applications for energy storage systems. This is probably some of the most, satisfying and rewarding systems are the systems we do down in the Caribbean, where we're taking islands that traditionally have had limited power or are running completely off of diesel generators, and we're able to work with those islands or villages to incorporate our energy storage system along with solar power to basically reduce their use of the generators. Cut the runtime down by 95%. So definitely
Yeah.
transitioning to green power and not only making them green, but there's some villages like in Haiti we worked with where they had no power before we deployed our systems down there. So just being able to provide power to some of these more remote villages, and give them more comfort in their living lifestyles has been both fun and rewarding.
Yeah, I bet. I mean, I think about those islands, and I know that almost invariably, that in the past they've had to import their energy resource, and not to mention the whole environmental impact of that. But those are fascinating projects you guys have done, and we've written some about those. So I'd encourage people to seek those out and learn more. Great specific there, Jason. But let's zoom out a little bit though and talk about interaction between distributed energy resources, such as renewables, and the overall power system, the grid. And what are the best methods that you see in stabilizing a power grid that is experiencing frequent fluctuations in renewable energy input?
Sure, and the challenges, with adding all this renewable power to the grid system is that power is only available when either the sun's shining or the wind's blowing, which is going green is great for everyone, but the utility has to be able to figure out how and when to use that power the best. And what happens is if you get too much power being put onto the grid, then you start to see these voltage and frequency fluctuations because there's too much power available and vice versa. If you know the sun goes away or the wind stops blowing, now the utility has to ramp up its power output, and again you see these fluctuations.
Mhm.
The great thing about energy storage and what we're trying to help develop in the market is rather than reducing the renewable power sources, to limit those fluctuations, what we're able to do is install these energy storage systems in distributed areas, in regions, to basically collect that power when it's being generated, and then when it's needed, then you can discharge the battery systems to provide that power. And ultimately, you're smoothing out the power that the utility is having to generate, and thus providing a more stable grid.
Yeah, I mean, balance is key, right? So, we think about the role that, as you're talking about, with energy storage solutions playing, enhancing that grid stability. It feels like this is an important addition to really complete that sustainability and resiliency equation, to really lock those in together.
Right.
Um,
And yeah, being able to distribute this power, so the energy storage really allows you to do lots of different applications to really enhance the grid. Like I mentioned before, when that power is being generated but not necessarily needed, we can store that power, and then we can discharge that power when the utility is experiencing higher peak times or peak loads on their system. You hear about different regions that are having to experience, rolling brownouts now, or in some cases even blackouts,
yeah.
where their grid capability just can't meet the demand that's required. And so what we're able to do with these energy storage systems is one of the things you can do is called load shifting, where you're moving that load, to different times. So you can, like I said, charge the batteries during low peak periods, and then discharge the batteries during those high peak periods. With another thing you can do is called peak shaving, where you're looking at the total grid usage, and really trying to limit the peak that either the utility is putting out, or more at a local level, limiting the amount of power that any individual, residence or commercial or manufacturing warehouse might be utilizing. And essentially, by doing all that, you're really regulating the voltage and frequency of the grid, trying to
Right.
make it stable, trying to see less fluctuations. Um, and then and then beyond that, one of the benefits of the energy storage systems is if there ever is a grid outage, or if there is, going back to these rolling brownouts, the energy storage system can be used to continue to supply power to those sites during those brownout periods or during those grid outages, to minimize any impact that those might have on the utility consumers.
Yeah, and that capacity is why we're seeing so much deployment of this of those type of assets lately. And I mean, so many gigawatts of solar, wind, and battery that are going into interconnection these days, or applying for interconnection. And Jason, how do you assess the capacity and feasibility of integrating all of this distributed generation into the existing grid? And really, I guess I'm asking, what are your concerns there, and how does technology alleviate those concerns?
Sure, yeah. Yeah, on the surface, it all sounds great. You put these energy systems all over the place, and you use them whenever you need it. But at a higher level, the concern and what the utilities have to, work towards, is being able to integrate all those systems together so that they operate as one larger, ecosystem. In the industry, they call that the DERMS system, or distributed energy resource management system. And what that does is basically you have all these regionalized energy storage systems, that can be located at neighborhoods or substations or business parks, and by interconnecting all those, through monitoring devices, and through these resource systems that can basically manage how they all interact at the same time. And it allows the utilities to be able to, assess, how much power they're generating and then send out these signals to these systems to do what they need them to do as, working at a higher level with the utility as opposed to at a local level with, the consumer and building out that infrastructure, that communication network is really going to be key to making all this work harmoniously together, going into the future.
Yeah, I don't think we can overstress that point. That you're absolutely right on about that. I mean, it's an interesting, challenging, exciting, but also scary time in a lot of ways. I mean, think about the switchgear, the transformer, the substation equipment folks, a lot of pressure to figure out how to configure infrastructure and meet the coming load demands with electrification of transportation and just how distributed and diffused that will be. And then you got the whole data center equation as well. So I think a question I have is what innovations or advancements have you seen in the smart grid technology for utility substations in particular?
Sure, yeah. So a battery system is a battery system, right? So there's many manufacturers of battery systems that can store the energy and discharge when needed. But really what's key to making all this work is what they call the energy management system or the EMS, which is what monitors all the equipment locally and makes the intelligent decisions on when to charge and discharge the batteries to meet all this grid support functions. And here at ELM, that's one thing, we've really prided our company on is we started by developing that energy management system first. And then once we were comfortable with that control solution, then we integrated the battery system around our control system. So, really to continue the development of the smart grids and like, getting all these utility substations to work together, it's really revolves around that communication network. Cybersecurity is becoming more and bigger concern across all
Right.
these platforms. So not only do you have to be able to communicate and control all these distributed energy systems, but you got to protect the systems, right? So cybersecurity plays a big factor into in making all this work successfully. So really, like I said, that the key technology has really been revolved around the ability to monitor all these systems, so the advancements in the controls and the monitoring and the sensors and everything that goes into making sure that the equipment is working as it should, making sure it's working safely, and making sure everything's being protected, all the data is being protected. So it's been a fun ride here, really. Like I said, the
Yeah.
last 10 years as this industry's developed and seeing that growth and how all these systems are being used and how these advancements are coming along. Not to mention just the fact that it is being more highly utilized in the industry. Naturally costs start to come down across the systems, which means it's more affordable and more attractive to companies and utilities to implement the systems, which just continues the growth of the overall industry.
Yeah, it is. And it is a pivotal time. I mean, everybody's watching. I even heard somebody with one of the major utilities last week say, our industry is cool, And so I think I think we agree with that, right? But Jason, sort of as we start to wrap up, I would say I wish we could all see around the corner and know just exactly how this goes, but really we have to get there, right? And we do have the technology to do that, right?
Absolutely. With the increase of electric vehicles and just the overall use of the electrical grid, the increase of population, our grid today is getting stressed, and we've got to figure out ways to make that grid more stable and reliable for us and going into the future. and renewable, power sources like solar and wind, and the use of the energy storage that allows them to, capture that power when it's available and then discharge it when it's needed is really key to stabilizing the grid going into the future. There's just not enough capacity to go around for all the increase in growth that the communities and the utilities are foreseeing, and I think this is all going to be key to making it work going forward.
Yeah, no, I see it that way as well. I mean, it's good stuff, and it's just such a great time to have a quick chat with Jason Petermeier, who is Chief Operating Officer of ELM Microgrid and ELM Solar. And thanks for joining me, Jason.
Oh, it's been a pleasure. I appreciate you having me on today.
Yeah, you bet. You bet. And thanks to all of you who are sitting in with us for this Microgrid Knowledge quick chat. It's great to have you here. I'm Managing Editor Rod Walton. Till we chat again, we'll see you soon.